Hey guys, this is for the AP Calculus AB sequence. We're in the section after fundamental theorem. We're actually using integration to solve problems. I'm doing checkpoint 1.23 from the section. The section is 1.4. And this checkpoint is related to a previous example. In that previous example, the person is using the wind and an ice boat to go sailing across a frozen lake. Well, what we have here in the situation is a slightly different context. So if you want to see both contexts, check out the example from the book, from our section. Here we've redefined the function. We see that we have a piecewise function. There's a top condition where the function is 20t plus 5, that's the guy's velocity, going from the first half hour, 0 to half of an hour as the condition. In the latter half, 1/2 to 1, there's a different velocity function. And altogether, both of those functions create some sort of a shape that looks like this. Now notice I used Desmos, and I wasn't sure at first how Desmos wanted piecewise functions to be written, so I just Googled it. You should do that too. And when I Googled it, I realized the condition goes first. I switched the x or the t to x because x's are graphed a little more freely in Desmos. And then I had the colon when then I put the function. So even though it's written in reverse order, it does the exact same thing. Use a comma to separate the second condition and the second function of the piece. Now, in this problem, if we want to find how far the total displacement, something to consider is that these lines are both above the x-axis. So therefore, the area under the curve of these lines is going to be positive. The total displacement is the total, the net displacement is the total displacement. So let's work it out. We can absolutely graph it. I wonder if I could even say this. Let me try this. I'm going to go f of x equals, I'm going to do the integral from 0 of f of x dx. I guess I have to press the up button. It's weird. The back button. It says 8.75. So I'm going to say that the integral of v of t equals from 0 to 1 is 8.75. Let me get the fraction amount as well. 35, oh, that's true. 9 times 4 is 36. So cut back a fourth. 35 over 4. But the goal is to prove it, right? The goal is to show using fundamental theorem of calculus and also how we can talk about splitting the integral up into two sections. There's the 0 to 1/2 section of our function plus the 1/2 to 1 interval for our function. So 20t plus 5 becomes 10t squared plus 5t. And I'm going to use the line notation. Without that pencil was not good. There we go. Line notation 0 to 1/2. Plus, now I have the integral of negative 10t plus 15. So the 1 becomes a 2. You divide by 2, we would have negative 5t squared plus 15t evaluated from 1/2 to 1. Okay, 1/2. 10 times 1/2 squared plus 5 times 1/2. 0 and 0 make that whole thing 0, so there's not even like a reason to look at 0 at all. Plus negative 5 times 1. You always got to do the top boundary minus the bottom minus the second one. So I'm leading off with 1/2 for this integral because 1/2 is the upper bound of the second or the first condition. Now I'm leading off with 1 in the second portion because we need to find the difference. We're subtracting, so to speak. So we're going to subtract away minus negative 5 times 1/2 squared plus 15 times 1/2. Put enough parentheses in there, make sure it's all closed. A little rewrite would be helpful here too. I'm trying to do this without a calculator for as long as possible. So 10 over 4 plus 5 over 2 minus 5 plus 15 plus 5 over 4 minus 15 over 20. All of these are over 4. So let's just, well, the common denominator is 4, the least common denominator, the LCM. So it'd be 10 plus, I got to put a 2 here to put a 2 there. So 10. Now I got to put a 4 on the bottom of this. It's already over a 1, so I got to put a 4 next to that. So it'd be 20. Then it would be plus 60. Hang on a second. I'm going to do this for a second. Plus 5 minus 30. All of this is to get a common denominator of over 4, which also matched what we had from Desmos. So then we have 10 plus 10 minus 20. That's going to cancel. 60 plus 5, 65 minus 30. Booyah, 35 over 4. Thank you so much. I think I'm going to call that person back. See you on the next video.